Heck coupling. Heck coupling is another palladium catalyzed cross-coupling reaction that takes place between aryl halides or vinyl halides and alkenes or substituted alkenes in the presence of base such as triethylamine. Here, the R group of the halide replaces one of the vinylic hydrogens of the alkene. One of the biggest advantages of the Heck reaction is its trans selectivity. If there is a substituent present in the alkene molecule, then in the product, this substituent will be in trans position with respect to the R group of the vinyl halide. Here are two examples for Heck coupling reaction where you can see bromobenzene reacts with ethylene molecule in the presence of triethylamine and palladium catalyst to give styrene as the final product. And here we have a substituent on the alkene molecule, right? This is an ester, and this ester group right here is in trans position with respect to the R group of the vinylic halide. So if you can see here, if you wanted to put the hydrogens, so let's put the hydrogens. So you can see that the two groups are in trans position with respect to each other. This and this are in trans position with respect to each other. Another important thing is the configuration of the double bond is preserved. Here it's trans. You start with trans, and this double bond right here is also trans. Right? This is also trans. So two important things. If there is a substituent, then the substituent will be in trans position with respect to the R group that is present in the vinylic or the arylic halide. And the second thing is the configuration of the double bond is preserved. Like the Suzuki coupling reaction, here again the first step would be the metal insertion, okay? So which is basically oxidative, which we generally call as oxidative addition. So we have the arylic or vinylic halide here, which reacts with the metal catalyst, and the metal will get inserted between carbon and Br. So it will get inserted here. Now this is going to react with the alkene molecule, alkene or substituted alkene molecule. So this step right here is called as oxidative addition. So we know that carbon is more electronegative than the metal, and therefore this is going to behave as a nucleophile attacking one of these sp2 carbons. Okay, and this is going to push the electrons here to attack the palladium metal. And the next step would be basically intramolecular elimination reaction, for which this hydrogen is going to get transferred onto this palladium, and the bond between carbon and palladium is going to break, and it's going to move towards this carbon-carbon single bond as a pi bond. So this is going to get transferred onto palladium, and this is going to transfer here. This would be basically syn elimination, because you can see that the two groups that are getting eliminated are in the same direction, right? Now you can see that the R group from the vinyl halide or the aryl halide has been transferred onto the vinylic carbon. And one of the hydrogens from the vinylic carbon has been transferred onto this palladium catalyst. And the next step is reductive elimination, where the metal will be kicked off from this molecule to form HBr, and the catalyst, regeneration of the catalyst occurs. Okay, so this is going to lead to the formation of HBr and the catalyst. Now looking at this reaction, we are forming an alkene and also HBr. The HBr could actually add to this alkene in an electrophilic addition reaction. In order to prevent this, we are adding the base triethylamine. The triethylamine will go and react with HBr to form this salt. And the regenerated catalyst will again react with another molecule of the aryl halide or vinyl halide to continue the process. So all of the reactants is converted into product. There are some important things to remember in Heck coupling reaction. Say for example, here the nucleophile, this carbon nucleophile can go and attack this carbon or this carbon, and accordingly two different products can be obtained. So in order to avoid the mixture of products and to increase the yield in a Heck reaction, then you have to start with symmetrical alkene. So for higher yields, you should start with symmetrical alkene. Or you can also start with alkenes where one of the carbons is highly sterically hindered. Say for example, if you also substitute with another group here, then this is the only carbon that will be attacked, right? Because of the steric hindrance on this carbon. Okay, so one sp2 carbon is sterically hindered. And the third thing is that let's say that you're going to have an electron withdrawing group here. So if it's going to withdraw the electrons here, then this carbon is going to be more positive, and therefore the carbon nucleophile can go and attack this carbon more effectively. So this is another way to increase the yield in the Heck coupling reaction. So electron withdrawing group on one of the sp2 carbons. So these are the things that you can do in order to increase the yields in the Heck coupling reaction. Here are two examples where you can see that there are electron withdrawing groups attached to one of the sp2 carbons, and as these withdraw electrons, right, this carbon will be more electropositive, and therefore the carbon nucleophile can go and easily attack this carbon, increasing the yields in the Heck coupling reaction.